Before life learned to breathe, the Earth had to learn how to cool. Before the first cell existed, the planet itself had to survive. This is not the story of how life began. This is the story of the moment life became possible. Before there was life, before breath, before memory, before even the idea of survival, there was fire. Not symbolic fire, not poetic flame, but raw planetary violence. A heat so intense that nothing could hold its shape, nothing could remain stable, nothing could endure long enough to be remembered. 4.5 billion years ago, Earth was not a home. It was not blue, not green, not alive. It was a broken, molten world, still forming, still suffering the consequences of its violent birth. The young sun burned fiercely above it, while space hurled debris without mercy. Asteroids and protoplanets collided with Earth again and again, each impact releasing energy powerful enough to melt rock, erase surfaces, and reset the planet's slow march toward calm. There were no oceans. There was no sky as we understand it. The atmosphere was thick with toxic gases rising from the planet's interior: carbon dioxide, methane, ammonia, sulfur compounds. The surface glowed red and orange, a restless ocean of magma stretching from horizon to horizon. Volcanoes did not erupt occasionally. They dominated the planet entirely. For millions of years, nothing changed. And yet, this was not chaos without meaning. This was the cost of creation. Before there was life, before breath, before memory, before even the idea of survival, there was fire. Not symbolic fire, not poetic flame, but raw planetary violence. A heat so intense that nothing could hold its shape, nothing could remain stable, nothing could endure long enough to be remembered. 4.5 billion years ago, Earth was not a home. It was not blue, not green, not alive. It was a broken, molten world, still forming, still suffering the consequences of its violent birth. The young sun burned fiercely above it, while space hurled debris without mercy. Asteroids and protoplanets collided with Earth again and again, each impact releasing energy powerful enough to melt rock, to erase surfaces, to reset the planet's progress toward calm. There were no oceans. There was no sky as we understand it. The atmosphere was thick with toxic gases rising from the planet's interior: carbon dioxide, methane, ammonia, sulfur compounds. The surface glowed red and orange, a restless ocean of magma stretching from horizon to horizon. Volcanoes did not erupt occasionally. They dominated the planet entirely. For millions of years, nothing changed. And yet, this was not randomness. This was the cost of creation. In 1956, American geochemist Claire Cameron Patterson, working in California, finally placed a number on this ancient chaos. By studying radioactive isotopes trapped inside meteorites older than Earth itself, he determined the age of our planet to be approximately 4.54 billion years. This discovery did more than give Earth a birthday. It revealed how long this violence had lasted and how patient the universe had been. Earth was ancient before it was alive. During this earliest era, known as the Hadean, the planet was too hostile for even the simplest biology. No cells could survive. No molecules could persist long enough to organize. Life, as a process, did not yet have permission to begin. One event defined this era more than any other. Roughly 4.5 billion years ago, a Mars-sized body collided with the young Earth. The impact was so immense that it tore molten material from Earth's mantle and hurled it into orbit. Over time, that debris gathered, cooled, and became the moon. The moon is not just a companion in the night sky. It is evidence. Proof that Earth's infancy was unimaginably violent. Proof that our planet endured destruction on a scale that defies intuition. After this impact, Earth continued to glow with heat. But something subtle began to change. Very slowly, the planet began to lose energy. Cooling is not dramatic. It does not announce itself. It happens quietly, invisibly, over spans of time so long that human language struggles to describe them. Earth radiated heat into space. Radioactive elements decayed. Impacts became less frequent. The surface began to harden, crack, and reform again and again. At first, any solid crust was temporary. Lava would break through, melt it, and erase it. But over tens of millions of years, these crusts lasted slightly longer each time. Cooling was winning, 1 degree at a time. As temperatures dropped, Another transformation began. The thick atmosphere, once dominated by steam, started to change. Water vapor condensed. Clouds formed. Rain fell. Not gentle rain, but relentless, boiling storms that lasted thousands of years. This rain reshaped the planet. As the surface cooled below the boiling point of water, liquid began to remain. Vast oceans slowly collected in the planet's lowlands. By around 4.3 billion years ago, Earth likely had stable bodies of water covering much of its surface. This was not speculation alone. In Western Australia, scientists studying microscopic zircon crystals discovered chemical signatures that could only form in the presence of liquid water. These tiny minerals carried memories from Earth's earliest days, whispering a quiet truth across billions of years. Water had arrived. With water came possibility. Water absorbs heat, moderates temperature, and allows molecules to move, collide, and combine without being destroyed. In water, chemistry slows down just enough to become creative. Reactions can repeat. Patterns can form. Information can persist. Yet even now, Earth remained lifeless. There were no organisms, no metabolism, no replication. The planet was silent in a biological sense. Only physics and chemistry ruled, obeying laws without intention or purpose. And still, something extraordinary had happened. For the first time in its history, Earth was no longer forbidden to life. This was the true threshold. Not the appearance of cells, but the moment when the planet became capable of hosting them. Scientists today still debate where life's first steps occurred. Some look to deep-sea hydrothermal vents, where heat and minerals flow endlessly from Earth's interior. Others imagine shallow tidal pools, warmed by sunlight and enriched by evaporation. Some suggest ice-covered oceans that protected fragile molecules from radiation. We do not know which path nature chose. But we know this much. None of them were possible before the Earth cooled. Cooling transformed chaos into patience. It gave molecules time. Time to assemble. Time to fail. Time to try again. For hundreds of millions of years, Earth waited in this fragile state. Almost ready, but not yet alive. The universe watched silently as conditions aligned, as temperature dropped degree by degree, as stability slowly replaced violence. Life did not begin in an instant. It was invited. The unknown still surrounds this moment, and perhaps it always will. There is no fossil of the first living thing, no photograph of the first division of a cell. The transition from non-life to life is hidden behind time itself. But the cooling of Earth tells us something profound. Life is not rushed. Life is not guaranteed. Life begins only when the universe becomes gentle enough to allow it. And when Earth finally reached that moment, when fire surrendered to water and chaos softened into possibility, the greatest story in the planet's history was about to begin. The Earth cooled, and the universe waited. Once the Earth had cooled enough to hold water, the planet entered its longest and most delicate experiment. There was no intention, no design, no guiding intelligence. Only matter obeying laws, energy seeking balance, and time stretching endlessly forward. Yet from this blind process, something extraordinary was about to emerge. The oceans became Earth's first laboratories. They were not calm, blue seas like today. They were dark, mineral-rich, and restless. Volcanic heat surged from the ocean floor. Metals dissolved into the water. Salts accumulated. Chemical gradients formed naturally, creating regions of imbalance where reactions could occur again and again. In these waters, atoms met under conditions that were no longer violent enough to destroy them instantly, but energetic enough to force them to interact. Carbon bonded with hydrogen. Nitrogen joined oxygen. Phosphorus entered unstable arrangements. These were not living things, not yet, but they were the raw alphabet of biology. For millions of years, chemistry repeated itself. Most reactions led nowhere. Molecules formed and broke apart endlessly. Failure was the rule. Success was rare. But nature had something no human experiment ever possesses: infinite time and infinite retries. Lightning cracked through the atmosphere, delivering bursts of energy into the oceans below. Ultraviolet radiation from the young sun penetrated the shallow waters, driving reactions forward. Meteorites, still falling though less frequently, delivered new elements and organic compounds from space itself. Even today, carbon-rich meteorites are known to contain amino acids, suggesting that some of life's ingredients were older than Earth. This was not a single experiment. It was millions of experiments happening everywhere at once. In the 20th century, scientists finally attempted to recreate this ancient chemistry. In 1953, at the University of Chicago, Stanley Miller, working under Nobel laureate Harold Urey, designed a simple but revolutionary experiment. He filled a closed glass system with water and gases thought to resemble Earth's early atmosphere: methane, ammonia, hydrogen, and water vapor. Then he introduced electrical sparks, simulating lightning. After only a week, the clear liquid inside the apparatus turned dark. Chemical analysis revealed the presence of amino acids, the building blocks of proteins. Life had not been created, but something just as important had been demonstrated. The chemistry of life could arise naturally. No biology was required. No guiding hand. Just the right conditions. This experiment did not prove how life began, but it shattered the idea that life required a miracle. It showed that the universe itself was capable of generating complexity from simplicity. Back on the early Earth, the experiment continued without pause. Near the ocean floor, hydrothermal vents released superheated water rich in minerals like iron, sulfur, and nickel. These vents created natural chemical gradients, where energy flowed continuously. Some scientists believe these locations were ideal cradles for life, offering both protection and fuel. Within tiny mineral pores, molecules could concentrate, react, and slowly organize into more complex systems. Elsewhere, shallow pools formed along coastlines. As tides rose and fell, water evaporated and returned, concentrating chemicals again and again. Sunlight provided energy. Drying cycles encouraged molecules to link together. Rehydration allowed them to move and interact. These repeated cycles acted like a slow rhythm, nudging chemistry toward greater organization. The Earth was testing every possibility simultaneously. At some point, molecules began doing something unusual. They started to copy themselves. This was not life yet, but it was the beginning of heredity. Certain molecules, likely early forms of RNA, could store information and make imperfect copies of themselves. Imperfection was crucial. Errors introduced variation. Variation allowed selection. Selection allowed progress. This idea, known as the RNA world hypothesis, emerged in the late 20th century as scientists realized RNA could both store genetic information and catalyze chemical reactions. It was a bridge between chemistry and biology, a plausible path from simple molecules to living systems. Once replication existed, even in its simplest form, the experiment changed forever. Now, success could accumulate. Molecules that copied themselves more efficiently became more common. Systems that protected themselves lasted longer. Chemical networks grew more stable. Gradually, boundaries formed. Lipid molecules naturally assembled into membranes, creating tiny compartments that separated internal chemistry from the outside world. The first protocells were born. They were fragile, inefficient, and blind. They did not think. They did not plan. But they persisted. They consumed energy. They maintained internal balance. They reproduced. The experiment had crossed a threshold. For the first time, matter was no longer just reacting. It was surviving. This transformation likely occurred more than 3.8 billion years ago, though no fossil records remain from this exact moment. Time has erased the details. Heat, pressure, and plate tectonics recycled the earliest crust, destroying direct evidence. What remains are chemical signatures, isotopic ratios, and patterns consistent with biological activity. In Greenland, scientists discovered ancient rocks containing carbon isotopes that suggest biological processing as early as 3.8 billion years ago. These findings imply that life began remarkably quickly after Earth became habitable. The planet did not hesitate. Once conditions allowed life, life appeared. The experiment succeeded not because it was efficient, but because it was relentless. Earth tried everything, everywhere, all the time. Most attempts failed, but failure did not matter. There was always another reaction, another cycle, another chance. This is the nature of the universe. It does not aim. It explores. The emergence of life was not a single event, but a transition. A slow, gradual shift from chemistry that merely happened to chemistry that remembered. From reactions that vanished to systems that endured. And once endurance existed, evolution became inevitable. The Earth was no longer just a planet. It had become a participant. For a long time, life remained invisible. It did not roar. It did not conquer land or sea. It left no obvious marks on the planet's surface. The earliest life on Earth was quiet, microscopic, and easily erased by time. And yet, it was real. It lived, it consumed energy, and it multiplied. The revelation of its existence would not come from stories or myths, but from stone itself. Billions of years later, humans would learn how to read those stones. The first undeniable evidence of ancient life came from structures known as stromatolites. These layered formations were discovered in places where time itself seemed reluctant to move forward. One of the most important sites lies in Western Australia, where rocks more than 3.5 billion years old still remain exposed at the surface. Within these rocks, scientists found layered patterns that could not be explained by geology alone. They were formed by colonies of microorganisms, mainly cyanobacteria, trapping sediment as they grew. Layer by layer, generation after generation, life left behind a record of its persistence. This discovery was revolutionary. It meant that life had already established itself on Earth astonishingly early. The planet had barely cooled, oceans had only recently formed, and yet biology had taken hold. Life did not wait. Once conditions allowed it, life emerged with remarkable speed. But the revelation went deeper than simple existence. These early organisms were not just surviving. They were changing the planet. Cyanobacteria possessed a dangerous new ability. Using sunlight, they could split water molecules and extract energy, releasing oxygen as a byproduct. This process, known as photosynthesis, seems ordinary today. But on early Earth, it was catastrophic. Oxygen was toxic to most existing life. For hundreds of millions of years, cyanobacteria pumped oxygen into the oceans. At first, it reacted immediately with dissolved iron, forming iron oxides that sank to the seafloor. These reactions created banded iron formations, massive geological structures still mined today. Their existence was first carefully studied in the 20th century, revealing a chemical record of rising oxygen levels. Eventually, the iron sinks filled. Oxygen had nowhere left to go. Around 2.4 billion years ago, it began to accumulate in the atmosphere. This moment is now known as the Great Oxidation Event. It was not sudden, and it was not gentle. Oxygen transformed Earth's chemistry, altered the climate, and drove countless anaerobic organisms to extinction. Life caused the first mass extinction on Earth. And yet, this destruction was also creation. Oxygen allowed for more efficient energy use. It enabled the evolution of complex metabolism. It made possible larger cells, more intricate structures, and eventually, multicellular life. The sky itself changed, turning from a hazy orange to the blue we recognize today as oxygen interacted with sunlight. The planet was no longer the same world it had been. This realization marked a turning point in our understanding of life. Life was not just adapting to Earth. Life was shaping Earth. In South Africa and Greenland, scientists studying ancient rocks found further evidence of biological activity in carbon isotope ratios. Living organisms prefer lighter carbon isotopes, and these subtle preferences remain recorded in stone. These chemical fingerprints confirmed that life was widespread long before complex organisms ever appeared. The revelation was no longer in doubt. Life was ancient. Life was powerful. Life was transformative. For nearly 2 billion years, Earth belonged exclusively to microorganisms. No plants, no animals, no eyes to see the sun or ears to hear the wind. Just bacteria and archaea dominating every environment, from boiling vents to frozen seas. This long microbial age was not stagnant. Evolution worked tirelessly beneath the surface. Cells developed new strategies, new metabolisms, new ways to survive. Some learned to live together. Others learned to live inside one another. One of the most important revelations in biology came from this realization. At some point, one cell engulfed another and did not digest it. Instead, they formed a partnership. The engulfed cell became a mitochondrion, the energy-producing structure found in nearly all complex life today. This idea, known as the endosymbiotic theory, was championed in the 20th century by biologist Lynn Margulis. It explained something extraordinary. Complex life was not born through domination, but cooperation. This partnership allowed cells to produce far more energy than before. With energy came complexity. With complexity came specialization. And with specialization came the foundations of multicellular organisms. The Earth was preparing for something entirely new. By around 1.8 billion years ago, the first eukaryotic cells appeared. They contained nuclei, internal structures, and greater organizational capacity. Life was no longer just surviving. It was experimenting with form. Still, progress was slow. For hundreds of millions of years, complexity advanced cautiously. The planet endured ice ages so severe that oceans may have frozen nearly solid. These snowball Earth events tested life's resilience, pushing organisms to the brink. Yet life endured, hiding in refuges, waiting for conditions to improve. And when they did, life responded. By around 600 million years ago, multicellular organisms began to appear in the fossil record. Soft-bodied creatures left impressions in ancient sediments, signaling a new chapter. Shortly after, during the Cambrian explosion around 540 million years ago, life diversified at an unprecedented rate. Eyes evolved. Movement accelerated. Predation began. The arms race of evolution reshaped life into forms both beautiful and terrifying. All of this traced back to a single revelation. Life was not fragile in the way humans often imagine. Given time and stability, life was unstoppable. The recognition of this truth transformed science. Earth was no longer viewed as a static stage upon which life acted. It was an evolving system, shaped by life and shaping it in return. Atmosphere, oceans, rocks, and biology were intertwined in a single planetary story. And in understanding this, humanity gained a new perspective. We were not separate from Earth's history. We were its consequence. The revelation was not only that life began early, but that once it began, it rewrote the rules of the planet. Earth became alive not in poetry, but in chemistry, not in intention, but in effect. The cooling of Earth had allowed life to begin. Life's emergence had allowed Earth to change forever. And this realization would lead to a deeper question, one that would shape humanity's understanding of its place in the universe. If life could transform an entire planet here, under these conditions, then what might be happening elsewhere, on worlds we have yet to see? The revelation did not end with Earth. It opened the universe. Once life had learned to survive, it did not stop there. Survival was only the beginning. What followed was transformation on a scale no molecule, no cell, and no planet could have predicted. Life altered Earth permanently. The oxygen released by ancient microbes reshaped the atmosphere, but that was only the first consequence. With oxygen came new chemistry. With new chemistry came new possibilities. Energy could now be extracted more efficiently. Cells could grow larger. Structures could become more complex. Evolution, once slow and cautious, gained momentum. Over millions of years, life expanded into every available niche. Oceans filled with microscopic ecosystems invisible to the naked eye yet immense in collective power. Chemical cycles emerged. Carbon, nitrogen, sulfur, and phosphorus began moving through living systems in repeating loops, linking the biosphere to the atmosphere and the rocks beneath. The planet was no longer governed by physics and chemistry alone. Biology had joined the system. As continents slowly drifted across the planet, life adapted to new coastlines, changing climates, and shifting oceans. Tectonic motion created mountains, shallow seas, and isolated environments. Each change forced life to respond. Those responses accumulated, generation after generation, shaping increasingly diverse forms. The emergence of multicellular life marked a profound turning point. Cells began to specialize. Some focused on movement, others on digestion, others on reproduction. Cooperation replaced isolation. Individual survival became linked to collective success. This shift reshaped ecosystems entirely. Predators appeared, and with them, prey evolved defenses. Shells hardened. Spines sharpened. Vision improved. Movement became faster, more precise, more intentional. The oceans transformed into arenas of interaction, competition, and balance. By the time life began to explore land, the planet itself had changed. Oxygen levels were high enough to support complex metabolism. An ozone layer formed in the upper atmosphere, shielding the surface from lethal ultraviolet radiation. What was once a barren, irradiated world became a place where life could exist beyond water. Plants were among the first to make this transition. By harnessing sunlight on land, they altered the atmosphere again, stabilizing carbon dioxide levels and producing vast amounts of organic material. Roots fractured rock, accelerating weathering and soil formation. Landscapes changed. Rivers carried nutrients. Forests emerged. Life reshaped the surface of Earth just as surely as tectonic forces did. Animals followed. Arthropods, amphibians, reptiles, and eventually mammals expanded into new territories. Each step brought new consequences. Ecosystems grew layered and interdependent. Extinction events periodically erased dominant forms, clearing space for new ones. Life proved resilient, rebounding after catastrophe again and again. Mass extinctions were not failures of life. They were resets. The asteroid impact that ended the reign of the dinosaurs 66 million years ago was one such moment. Darkness fell. Climate shifted. Most large organisms vanished. Yet small mammals survived, adapted, and diversified. From this lineage emerged primates, and eventually, humans. Humanity was not an inevitable outcome, but it was a possible one made real by billions of years of accumulated consequences. The cooling of Earth allowed chemistry to stabilize. Stability allowed life to begin. Life altered the planet. A changed planet allowed intelligence to emerge. Humans inherited a world shaped by life long before them. The oxygen they breathe is biological in origin. The soil beneath their feet is the product of ancient organisms breaking down rock. Even the fossil fuels that power modern civilization are compressed remnants of long-dead life. Every breath is a legacy. With intelligence came awareness. Humans did something no other species had done. They began to question their own origins. They looked at the rocks, the sky, the oceans, and asked how it all began. They traced their lineage backward, from complex societies to simple cells, from cells to chemistry, from chemistry to a cooling planet. This awareness carried responsibility. For the first time, a species gained the ability to alter the planet consciously. Agriculture reshaped ecosystems. Industry transformed the atmosphere. Technology accelerated change faster than natural systems could adapt. Humanity became a geological force. This is the ultimate consequence of life's long experiment. The planet that once waited patiently to cool now responds to the actions of its most recent creation. Climate shifts. Species disappear. Systems strain under pressure. Earth, once shaped by unconscious life, now faces deliberate influence. And yet, this too is part of the story. Life has always changed the planet. The difference now is awareness. The question is no longer whether life can transform Earth, but whether it can do so wisely. The consequences of Earth's cooling extend beyond biology and beyond humanity. They reach into the universe itself. Our existence proves that planets can transition from chaos to complexity, that chemistry can give rise to consciousness, that the universe is capable of knowing itself through living systems. Every telescope pointed at distant stars carries this implication. If Earth could do this once, perhaps it is not alone. Perhaps countless worlds are following similar paths, cooling, stabilizing, experimenting, waiting. The Earth's history is no longer just a local story. It is evidence. Evidence that life is not an anomaly, but a natural outcome under the right conditions. Evidence that complexity can emerge from simplicity. Evidence that the universe is not sterile, but creative. The consequence of Earth's cooling is not just forests, animals, or humans. It is meaning. Meaning forged without intention, shaped by time, and discovered by beings capable of reflection. Beings who can look back across billions of years and recognize the fragile chain of events that allowed them to exist. The molten world became a living planet. The living planet produced awareness. And awareness now stands at the edge of its own responsibility. The experiment continues. At the end of this long journey, there is no explosion, no final conquest, no dramatic conclusion written into the fabric of the universe. There is only reflection. The Earth cooled. Life began. And now, life looks back. For the first time in the planet's history, matter has become aware of its own origins. Atoms arranged themselves into molecules, molecules into cells, cells into minds capable of memory, curiosity, and wonder. The same elements forged in stars now ask questions about stars. The same planet that once burned without mercy now carries beings who contemplate its past. This is not destiny. This is consequence. When we trace life back to its beginning, we do not find intention. We find patience. We find time operating on unimaginable scales, shaping outcomes not through purpose, but through persistence. Earth did not know it would host life. Life did not know it would become complex. Complexity did not know it would become conscious. And yet, here we are. The cooling of Earth was not a moment of triumph. It was a moment of permission, a quiet shift from violence to balance, from instability to continuity. It allowed chemistry to slow down, to repeat itself, to remember. From that memory emerged heredity. From heredity emerged evolution. From evolution emerged awareness. In this light, life is not something added to the universe. It is something the universe does when conditions allow. This realization reshapes how we see ourselves. We are not strangers on this planet. Every cell in the human body carries a history billions of years old. The iron in our blood was forged in ancient stars. The oxygen we breathe was released by microbes long extinct. The water in our veins once flowed through primordial oceans under alien skies. We are Earth remembering itself. And memory carries responsibility. For most of its existence, life changed the planet unconsciously. Microbes altered the atmosphere without knowing it. Plants reshaped landscapes without intention. Animals transformed ecosystems simply by existing. Humanity is different. It understands that its actions matter. It can see consequences before they fully unfold. This awareness is unprecedented. For the first time, a species stands at a crossroads not imposed by nature, but by its own choices. The same intelligence that allows us to uncover Earth's ancient history also gives us the power to alter its future. Climate, biodiversity, oceans, and atmosphere now respond to deliberate action, not blind process. The question becomes unavoidable. Can a species born from billions of years of balance learn to preserve that balance? Reflection does not demand guilt. It demands understanding. The story of Earth teaches that change is inevitable, but collapse is not. Life has survived mass extinctions, frozen worlds, burning skies, and planetary trauma. What threatens Earth now is not change itself, but speed. Systems evolved to adapt over millions of years are being pushed to respond within centuries. The cooling of Earth teaches patience. Life teaches resilience. Awareness must teach wisdom. Beyond Earth, the reflection widens. When we look into the night sky, we no longer see empty points of light. We see possibilities. Every star with planets carries the same question Earth once asked silently. Can chaos become calm? Can fire become water? Can chemistry become life? The universe is vast, ancient, and patient. It does not hurry life. It waits for the right conditions. Somewhere, right now, other worlds may be cooling. Oceans may be forming. Molecules may be repeating their first successful patterns. Life may be beginning without witnesses. And just as Earth once did, those worlds will not announce it. Life begins quietly. This perspective humbles us. It reminds us that intelligence is not guaranteed and awareness is rare. If life is common, then consciousness may still be precious. And if consciousness is precious, then it carries weight. To exist is not enough. To understand is not enough. To choose wisely becomes essential. The Earth does not need us to survive. It has endured far worse than anything humanity has caused. But the version of Earth that allowed human existence is fragile. The narrow band of temperature, chemistry, and balance that supports complex life is not permanent. It must be maintained. The cooling of Earth was a gift of time. Time allowed life to begin. Time allowed it to diversify. Time allowed it to become aware. What we do with that awareness determines the next chapter of the story. There is no guarantee that intelligence endures. Many species dominated the planet before us. All believed, in their own way, that the world belonged to them. None were permanent. Humanity's uniqueness is not dominance. It is reflection. To reflect is to see oneself as part of a continuum stretching back to molten rock and forward into uncertainty. It is to recognize that the boundary between nature and observer does not truly exist. We are not outside the story. We are within it. The earth cooled. Life began. Consciousness emerged. And now, the universe watches through our eyes. Perhaps that is the deepest meaning of this story. Not that life exists, but that it can understand its own improbability. That from chaos emerged beings capable of gratitude, caution, and care. The universe did not promise permanence. It offered possibility. Whether that possibility becomes wisdom is the final experiment, and it is still unfolding.